In this activity, we're going to calculate the embodied water in several types of flooring. This sheet is available on the LMS in the lectures page, and so you can print it off and have a practice yourself on this type of calculation. So we want to do a comparison between two types of construction assemblies, and so we have a typical wooden floor and a typical concrete slab floor. In order to do the embodied water calculation, we basically have to do a couple of things. First is to calculate the volumes of material involved in each of the two types of flooring, and then using a table of embodied water coefficients, which is over the page, and we'll look at it in a moment, we can then calculate the embodied water. Exactly the same technique is used for doing an embodied energy calculation. So typically with this type of calculation, you would do the calculation for a functional unit such as 1 square metre of flooring, so that then if you're trying to calculate the embodied water for a whole building, you could multiply the floor area of the building by the embodied water per square metre. So let's go through the calculation for the wooden floor, and then I'll leave the calculation for the concrete floor as an exercise for you. So just to understand the diagram for a start, so we have a floor. It is made up of floorboards that are sitting on top of what are called joists. There are 4 joists in this particular floor, and those joists sit on what are called bearers, and there are two bearers in this floor. In the building, these bearers would then sit on piers or pylons, or maybe go between 2 walls in order to support the floor, and that's not considered as part of this calculation. Other aspects of the floor would normally have some sort of surface treatment, and so we could consider an oil stain as a surface treatment for this floorboards. Now, so just to confirm, the dimensions of this floor are 1 metre by 1 metre, giving a total surface area of 1 square metre, and therefore the lengths of the joists that are supporting the floor are 1 metre, the lengths of the bearers are also 1 metre. So first of all, we need to construct a little table that just has the materials that are involved. So we have a column here for materials: oil stain, hardwood flooring, hardwood joists, and hardwood bearers. And we need to know the quantity and units of each of these materials. Now, in this type of calculation in the construction industry, materials that are put on in thin coats or are not defined by their thickness would generally be quoted in square metres. So for example, oil stain, we don't try and work out the thickness of the stain, we just quote it in square metres. Similarly, if you were looking at something like carpet would be quoted in square metres of carpet, and using that for the calculation. For the oil stain, the quantity is 1 and the unit is square metres. For the hardwood flooring, we have a quantity of 0.02 and the unit of cubic metres. Now let's just do a quick calculation to see where that came from. So for the flooring, we have the area is 1 square metre, the thickness equals, and we had 20 millimetre thick floorboards, 20 millimetres. So the volume equals the area by the thickness, so that equals 1 metre squared by, and now we have to get this in the same unit as the area, so this is 0.02 metres, and the volume comes out at 0.2 metres cubed. And so here we have 0.2 metres cubed. Now let's do the calculation for the joists and the bearers. So for the joists, that's these ones. So we have Now we don't have an area of joist, we have to work out the volume for each of these particular joists. So the volume is going to equal the length by the width by the height by the number of joists. And this is 1 metre. The width of the joist, 100 by 50 are the dimensions of the joist. So this is 0.1 metre, 100 millimetres, 0.1 metres by 0.05 by 4, because we have 4 joists. And if we calculate this out, we get 0.2 cubic metres of wood in the joists. Now for the bearers, we have the same sort of calculation, 1 metre long by 0.1 metre by 0.075, and there are 2. And so this comes to 0.015 cubic metres. So if we transferring these calculations to our worksheet, we have 0.02 metres of hardwood flooring, 0.02 metres cubed of joists, and 0.015 metres cubed of hardwood bearers. Now, so we have the volumes of the material. We now need to go to a source to find the embodied water rate in kilolitres per unit. On the back side of this table, there is information taken from a book, Life Cycle Assessment in the Built Environment by Robert Crawford, who was the person who gave a lecture in Reshaping Environments on embodied water. And so these tables of these sorts are also available widely on the internet. You just need to be very careful about the source of the data. So in this table we've got materials, so we've got timber, hardwood, and it's using the functional unit of cubic metres, which is corresponds with our value. And then in this table we've got coefficients for both embodied energy in gigajoules per unit, so gigajoules per cubic metre, and we've also got an embodied water coefficient. And so for hardwood, 16.28 kilolitres per cubic metre. And then the other material we had was an oil-based stain. Now there isn't stain on this table, but paint is the nearest item, so we've got an oil-based paint. A stain is really just a clear paint, and it has units of square metres and a coefficient of 0.219 kilolitres per unit. So transferring those back to our table. So we've got oil stain, 1 square metre, 0.219 kilolitres per square metre, and we just multiply these two values together to get the embodied water in kilolitres, and then hardwood flooring, 0.02 metres, 16.28 was the coefficient, multiply those, and so on for the 3 figures. And so we can calculate the total embodied water in the material. And so if we just top these up, so 4 and 6 is 10, 16, 25, carry the 2, 2 and 4 is 6, 2 is 8, and 2 is 10, and 1 is 11, carry the 1, 3, 3 is 6, and 3 is 9, and 2 is 11. So 1.15 kilolitres per square metre of floor. So the same exercise can be undertaken for the concrete slab. So just some things to note. In the concrete slab there is a couple of things. 25 MPa is the strength of concrete, and concrete can be made in different strengths and will have different embodied water and energy depending on the strength. So in the table when we look at concrete, there are different strength components there per cubic metre of concrete to be aware of. Now, the other thing about concrete slabs is that they will have steel reinforcement embedded in the concrete. So, within the concrete, there'll be rods of steel to help prevent cracks in the concrete and to give it strength. And up in the specification, it says make an assumption of 100 kilograms of steel reinforcement per cubic metre of concrete. So in these terms, we can work out the volume of concrete, and then for every cubic metre of concrete, we have 100 kilograms of steel. And on this one, we have ceramic tiles, which will be like a surface treatment in square metres. And so once again, we can note down the materials. So we can have tiles, concrete, steel, and continue on with this calculation. So the concrete, so using that figure there, steel, we have steel in tonnes. So a tonne is 1,000 kilograms. So in your calculation before, you need to adjust the calculation. So instead of kilograms, you have a value in tonnes. And we have ceramic tiles. So just to give you a chance to do this calculation yourself, the embodied water for this comes to 3.29 kilolitres per square metre of floor. And perhaps just one final point, a kilolitre is 1,000 litres. So we can see in this case that the embodied water of the concrete floor is about 3 times as much as the embodied water of the timber floor. So I'd encourage you to go through and do the calculations for the concrete slab, see if you come up with the same value, and then do the same calculation for the embodied energy. And for that, you're just using the same base data, but from the table, use the embodied energy coefficient, and you can compare the energy content of the two floors. So one can see for this type of exercise, we can go through and given the construction materials of a building or a landscape, one can calculate the embodied water and energy. The other thing is just to be aware of the quality of the data, and so the values of embodied water and energy, even though they are quoted to quite high precision, so for example for significant figures for the steel, one should be aware that different production processes end up with different amounts of water and energy use, and this is a typical value, and if one wanted to get more detailed, you should be looking at local values for a particular product. And so in Victoria, for example, if a product is using electricity generated from the brown coal electricity power stations, then things like the embodied energy in those materials, if one considers right back to the energy from the coal and the embodied carbon dioxide, which is another thing that we might calculate, will be quite different than if we were using electricity generated from gas or from hydro sources. In particular, aluminium is a material that uses a lot of electricity in its manufacture, and so electricity manufactured in Australia, which will be based on coal-fired power stations, would have a much higher energy content than aluminium produced from Iceland, which uses a lot of hydroelectricity in its production. So always be thinking about the detail behind the data. It's all very well ending up with some very precise looking figures, but one needs to be well aware of what lies behind those figures in terms of potential environmental impact.